Hello everyone. So many of you would have wondered that what is electricity and why we cannot see electricity like we can see the water flowing through a river. So yes, it's a fact that we cannot see electricity flowing through the conductors, but electricity has become very essential in our day-to-day lives. We can use electricity in the form of lights, in the form of equipments, in the form of heating elements which we use in our heaters. So today we are going to see very basic topic, that is what is electricity and how it is generated and what are its essential benefits and uses. The building block of electricity is atom and the charges. Atom is the basic of our physics phenomenon. So at its core, electricity originates from the fundamental building blocks that are atoms. Atoms are minuscule particles comprises of central nucleus and the electrons which are revolving around it. And it also has positively charged protons. So the phenomenon of electricity begins with the fascinating movement of these charged electrons. So electricity is nothing but the movement of electrons. Electrons flow in the outermost shells of an atom that are always tightly bound. They can be dislodged and pushed from one atom to the another, creating chain reaction. So the electrons can be pushed from one atom to the other, so that if one atom becomes deficient of electron, it becomes charged as positive. So what is electric current? This is continuous and directed flow of electrons through a conductive material. That is precisely what we define as electric current. It's the essence of how power moves. Then the nature's example can be the electron flow is lightning. The lightning which we see in rainy season is nothing but live example of electricity, which is nothing but movement of electrons. So this is how a lightning stroke appears in rainy season. So the phenomenon of lightning is natural electrical discharge which creates a giant spark of electricity in atmosphere capable of extreme heat. So the lightning stroke is nothing but a live example, natural example of the flow of electrons. So what are the voltage comparison? So in household we use 120 volt or 230 volt, whereas in lightning the voltage can be 1 billion volt. In transmission line we use 11 kV, 33 kV up to 760 kV. During lightning, when the windows, that is very obvious. Seek immediate shelter in a sturdy building or vehicle. Avoid open fields and tall objects. Very common phenomenon is static electricity in everyday shocks and surprises. You would have played this game when we were small. When we rub a balloon on our hairs, they develop a static charge. So static charge is nothing but exchange of electrons. When we rub the hair, the electrons are dislodged and they are gathered on the surface of balloon. So they attract our hairs. So that is a very natural and common static electricity example. Also we get carpet shocks when walking across a carpet made up of static charge on our body. Then sudden jumps. Unlike continuous electric current, static electricity involves electrons jumping suddenly from one object to the other to restore equilibrium rather than flowing continuously. So these are the example of static electricity. So how electricity powers our world? So power generation. Electricity is generated in a power station. For example, a thermal power station which burns the coal, produces a steam, and a generator is run which produces electricity. Then the electricity which is produced needs to be transmitted with the help of high transmission lines which carry electricity over long distances efficiently. Then we have substation where transformers are located which regulate the voltage. Transformers play a crucial role increasing decreasing the voltage to safely and efficient transmit electricity to homes and businesses. Then comes the distribution and usage. Finally, the electricity which is generated, transmitted, and regulated is finally electricity is distributed to our homes and devices measured in volts and ampere, that is current. So, electricity generation is done with the help of coal and also with the help of sun. So, fossil fuel such as coal and natural gas have been major contributors for burning heat, water, and spin the turbine, which will generate the electricity. Then, nuclear fission generates heat to produce steam, driving turbines without carbon emissions. Then, we have wind power. Wind turbines harness kinetic energy directly spinning to generate the electricity. Then, solar power. Photovoltaic panels convert sunlight directly into electrical current. So, power plants are essentially choose various methods to spin turbines, which then move electrons to create electric current. The shift towards renewable sources is vital for a sustainable future. Traditionally, we have been using fossil fuels such as coal to generate electricity, which has proven to be degrading our environment due to emission of carbon dioxide and other harmful gases. And in order to be environmental friendly, we have to move from our traditional fossil fuel electricity generation to the renewables. Renewables such as wind power, geothermal, and solar power are renewable energy resources which are sustainable with our environment. How electricity and technology are observed in our nature. So, what are the technological applications? Smartphones, computers, lights, motors, and communication systems, transport, and countless modern conveniences use electricity. Then, what are natural occurrences? Electricity is essential for biological functions. Our nerve signals and brain activity are all electrical. So, the senses which we can feel are nothing but electrical signals which are passed on by our nerves to our brain, which senses various signals. We have seen the example of lightning, and then certain marine animals like electric eels use electricity for defense and hunt. This is the comparison of speed and scale of electricity. Speed of light and speed of electricity are the same. Then we also have seen what are the voltage in lightning stroke. It can go up to 1 billion volt. Lightning currents can go up to 30,000 amperes of current, which is very huge. Then home measurement, which is done in kilowatt hour, which is the basic measurement of electricity. Then to conclude, electricity is nothing but it's an invisible force that powers everything in our world. It has ubiquitous influence which is present everywhere. To understand responsibility of use of electricity, a deeper comprehension of electricity allows us to appreciate its critical role and encourages us to use it wisely and efficiently. What can be the future outlook? The ongoing evolution towards cleaner, smarter, and electrical systems promises a more sustainable and electrified future for our planet. So this was basic understanding of the topic what is electricity. We have seen how electricity is generated, what are its building blocks, and how it has become so important in today's world. For more such content, follow our channel